Hello, Columbia Heights physics students. I'm Aaron Brenneman, and I'm going to be helping out in this class. I wish I could speak Spanish. I only know a few words, but three of the words I know are "si se puede." We can do this. And I believe we can do this in physics class. One of the most important things to know about science classes is that the science classes use words very carefully and very specifically. So, for example, motion. Motion just means moving, right? But in science, when you're trying to do something difficult, like take a space shuttle and launch it to the moon, you have to be very exact, very careful. It's not enough to say the moon is far. You have to know exactly how far and what's all going on. How's the moon moving? How's the earth moving? And that's one of the reasons science uses those words very exactly. And it can be tricky for people who aren't very exact on how they understand it. So that's one of the things we're going to be looking at today, is understanding some of these words in physics that mean very special things. So motion is when something is changing position compared to something else. Usually we're talking about compared to the earth. Like as I start walking, I'm in motion compared to the whiteboard, and you can guess I'm in motion compared to the earth and the other things around me, but I'm not in motion compared to the camera, or at least very, very little, because I'm holding the camera in place. So the camera and me are not in motion compared to each other. And also, motion does not always mean going somewhere. Going somewhere is one kind of motion, but if I'm standing still but turning, that's also still motion. Now we're going to learn a little more about motion. Right now I'm standing by a little X made out of markers. And I'm going to pretend I'm giving myself orders. Move north 5 meters, which for me a meter is about one step. 1, 2, 3, 4, 5. Now, move west 2 meters. 1, 2. Now move south 5 meters. 1, 2, 3, 4, 5. How far did I come? Depends on how you measure it. Started from right there. So this is what I did. 5 meters that way, 2 meters that way, and 5 meters back down. The distance is just how far I traveled in total. So 5 plus 2 plus 5, 7, 12. I traveled a distance of 12 meters. But displacement just looks at how far is where I ended up compared to where I started. That's only 2 meters. So the displacement is just 2 meters. I could say, hey, how could it just be 2 meters? I'm getting tired already. That's because of how those two things are different. Distance is the total of the movement. Displacement is just what's the difference from the start to the finish. And that brings us to two different ways of talking about distance. One way is scalar. That's where you just have a number. 12 meters is a scalar measurement. Or 50 pounds. That's a scalar measurement. It's just a number. You have a unit of measure. Pounds, meters, even speed. So if I was walking at 2 meters a second, that's the speed. How far was I walking in meters, and how are we measuring it in seconds? So 2 meters a second is a speed, and it's a scalar measurement. Vector, on the other hand, is a number that also gives you a direction. And if you notice at the beginning, I walked 5 meters north. That's a vector because it's not just a number, it's also saying which way. So I walked 5 meters north, then 2 meters west, and I ended walking 5 meters south. which made a total displacement of 2 meters. So why does all that matter? Let's think back to our example of the space shuttle. So you probably know the Earth is spinning, and it's also spinning around the sun in a giant rough circle. And at the same time, the moon is spinning around the Earth. So to calculate, where does the shuttle need to fly? Because if it just shoots at the moon right now, by the time it gets there, the moon's going to be long gone. So you can think in your mind, like, why is it important to understand the difference between distance and displacement, between a scalar measurement that's just the number or the distance, and the vector that's also specific about the direction? Trying to hit a moving target like that, you have to know these things very exactly. So this was just a fun little video. I hope helps make sure everyone understands what we mean by motion when we're talking in science. And also what we mean by displacement, distance, and then the difference between scalar and vector measurements. I'll see you soon.